This is exercise 2-3. We are substituting our original potentiometer from exercise 2-2 with our VEX potentiometer shown here. Our bill of materials are essentially the same. We have our Arduino microcontroller. We have our USB power cable where power is being sourced from the laptop here. We have a few wires, red designating our 5-volt power, and then our black wire is designating ground. We have our green wire here, which is our signal wire that's actually connected to the analog port here on A0. We have our breadboard, and on our breadboard we have this yellow wire, which is our output port, and that is fed in series with this flashing LED as well as this 22 ohm resistor that is going back to ground. So, and of course our VEX potentiometer. Our black is ground, our red is our 5-volt power, and the white is the signal, the control signal, which we will be controlling via analog as we turn this modified knob, which is actually a pin top. As we turn this, notice that the LED rate becomes more and more frequent as it flashes. And notice on the Arduino itself that transmission light LED is flashing as well. When turned all the way, it is on, and as well as the LED on the breadboard. Once I start to turn it in the opposite direction, which is actually clockwise, the frequency of that flash decreases. And I will show you on the program itself. As we turn that knob counterclockwise to increase the frequency, notice that bit rate is decreasing. The amount of bits is decreasing from 1023 to 739 to 565, all the way down, if we turn it all the way down to 1 and 0, alternating, of course. And this is shown in our serial monitor here. If we turn it clockwise all the way back up, you'll notice that the values increase. All the way back to 1023. So I have removed the VEX potentiometer and replaced it with the VEX line tracker seen here. Essentially, the line tracker is using infrared light sensing technology. The sensor emits an infrared light onto a surface, and the reflective light is picked back up by that sensor. And based upon the reflectiveness, the sensor will determine the intensity of that reflective light. And as a result, on our serial monitor, you will notice the analog values shown here will change depending upon the surface that the reflective light is essentially facing. So on a surface such as, we'll use the black portion of this notebook here. We'll hold that sensor over that portion, and you will notice that that value is ranging among the 900s. Somewhere between 960 and 999. Then what we're going to do is we're going to take the opposite, and we'll use this white portion of the paper, and we'll just hold the line sensor over that. And as you can see, the value is massively smaller. It's almost the complete opposite. Instead of having 999, those values are ranging in double digits instead of single digits. And as you can see here on the screen, it's 74 to 75. And just for an arbitrary color, we're going to use the Arduino Project's book bronze portion of this cover. And as you can see here, those values are approximately between the high 400 range to the low 600. And that's essentially the VEX line tracker. Exercise 2-3, we have removed our VEX line tracker and replaced it with the VEX push button, or also known as the bumper switch. In this setup, we had to modify our Arduino IDE so that it can recognize a digital read as opposed to analog. So once the button is pressed, our LED light will light, and when it is released, it will turn off. So let's take a look at our program here. We have kept a serial begin instruction at 96 baud rate. Here we have put for the pin mode 2, which has been designated on our digital input, and thus denoted here the input pull-up. And pin mode 13, that's our output. So our LED is actually connected in series with this digital output here. As you can see in our serial monitor here, down below, we have ones in this going up. This is the constant up-to-date digital. But once that button is pressed on the VEX push button, they go to 0. Once the button is released, back to 1. Again, when the button is pressed, it goes low, and once it's released, it goes high.